Okay, hopefully we can get this last video in one piece. I'm gonna go ahead and just talk about the next two and what I did first, second, and third. Thought it would save some time for writing. As far as giving the vertex form, I'm gonna go ahead and underline vertex form for this one, and for vertex form I can get the vertex quickly. 2, -3. Remember, the 2 is positive. Also, the dilation is right here before the x. The dilation is 3. In order to figure out the x-intercepts, or even x and y-intercepts, I needed to multiply it out, which is what I did here. And you can pause the video and try it and then pick back up and see if you got the same answer. And so when I did that, I got all the way through to here, 3x squared minus 12x plus 9. And if I plugged in 0, this would become 0, this would become 0, so all that's left is 9, so my x-intercepts are 0, 9. And then last, to be able to figure out the x-intercepts, I factored back out the 3, and by doing that, I was able to factor x squared minus 4x plus 3 into x minus 3, x plus 1, and from here I was able to get my x-intercepts, -1 and a +3. And then for the last one, given the vertex form, oh, that is a mistake. That should be standard form. Okay, and given the standard form, I can easily, if those x is equal 0, I can get the y-intercept. And I can get the dilation. Dilation equals 1. I can factor the standard form and get my x-intercepts, and then I would complete the square to get my vertex. Okay, so 33, 34, and 35 are really nice examples of how you can get different pieces of information from different forms of the quadratic equation. Each one is special in their own way. Okay, last page. Again, I'm going to just talk about it. I'm going to show you where I started for 36. This is the one I started with first. In fact, I kind of want to cover the others up so you're not getting too anxious and just copying. Standard form, I can factor. I found factors of 15, 1 and 15, 3 and 5. 3 and 5 work to give me 8. And if I make them both negative, that gives me my -8. Multiply them, that gives me a +15. So I'm able to get the factored from the standard form. I can also, so I got the factored form. I can also get the vertex form from standard form by completing the square. And that's what I did down here. For 36, I moved my 15 over. I did b divided by 2 squared, so -8 divided by 2 squared is -4. Square that and I get 16. So plus 16 minus 16. So my perfect square is x minus 4 squared. Remember, the formula for that is on the back wall. X plus b over 2 in parentheses to the quantity squared. And then 15 minus 16 is -1. So I can put that right up here in vertex form. So remember, if you're given standard form, you can get both vertex and factored forms from that equation. For number 37, I can't go from vertex to factored. I have to go from vertex to standard and then back to factored. So the very first thing I did was multiply this out, and I think I did that. I just did a quick little box thing to show you that you can do it this way. Multiply x minus 3 times x minus 3. Don't forget to subtract your 4. And you should get x squared minus 6x plus 5. Once you get that, again, factor it out. So the key is get everything into standard form, vertex or factored, and then you can get the other form that you're missing. So same thing for number 38. In this case, I was given factored form. I multiplied it out to get standard form, completed the square to get vertex form. And I've already explained completing the square. So practice these a few times. I highly encourage you to, once you're done with the exam over the weekend, especially for the ones taking the exam next week, to recopy it on all the problems that you worked out. It'll help solidify your understanding and you will do better on your exam. Plus, if you turn in both your reviews, the original and the copied one, I can give you some bonus points. The last problems are a little bit harder because they have a dilation. It's not just a equals 1. My vertex for this one, I'll do one at a time. My vertex for this one is 4, positive 8. So I graph that right here. And since a is negative 3, it opens down. And for my first points, I can go down 3 over 1. And it doesn't matter. I can go down 3 over to the right one, start back at the vertex, down 3 over to the left one. I do have a point down here. It is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 times 3 is 12. I think that's the pattern. But you could also plug in 2 in here. 2 minus 4 is negative 2. Like if x equals negative 2, I mean positive 2. So you get negative, I'm talking too fast. Okay, let's say I want to figure out where the graph hits at x equals 2, this part of the graph. It's going to hit somewhere on this line. Of course you know it's going to hit there because I have it graphed. But if I plug in negative 2 into this part, that's positive 2 minus 4 equals negative 2. I can't get the fact that I've already subtracted 4. So I'd have negative 2 squared, which is 4, times negative 3 is negative 12. Negative 12 plus 8 is negative 4. So at 2, negative 4, that would be my next point. You don't have to graph that, but I just wanted to show you an easy way to get your next couple points. And then for the last one, my vertex is negative 3, 5. Label it if you can. Remember to do so. That's more credit I can give you. And that way, if you do mess up the dilation, I can at least give you partial credit for getting the vertex correct. And for this one, again, up 2 over 1. It opens up because it's positive. And again, that's on my back poster. And then the last thing about the exam is this essay question. Use problems number 36 to 38 up here. And just tell me in words how you get from one form to the other. You could use any of these examples and write them down in part of your essay. At least give me a paragraph on how you convert. How do you get from standard form to vertex? How do I get from standard form to factored? How do I get from factored to standard? And how do I get from vertex to standard? That is plenty of things to write about. Good luck on your exams. I hope all of you do wonderfully. Study hard.